community call, January 25th. And so go off camera here. What I'm presenting on this side is the notes we took last week and the things we talked about. And last week we talked about PR 296, and we had some slides from AMD where they talked about adding to the processing pipeline, specifically metering and the changes in the pipeline here, 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 and here. And we didn't quite get through this metering bucket IDs if we want to pick up that part of the conversation. And then switching topics, we talked about moving to the Linux Foundation, and I put in a tip in the notes for the EasyCLA. I put that in the notes that I sent out on Saturday. And then, of course, PRs. So I didn't know if we wanted to kick off today talking about PRs or if we wanted to pick up this metering bucket IDs conversation. You guys tell me, are there any urgent PRs? I know that Prince has been working a lot on, was it 309? 309 has had a lot of comments, Prince.
Yeah, 309, I have addressed most part of it.
Yep,
So
I saw that. Because Hanif had something he asked, and then Vijay, and it looks like it's taken care of. So we hadn't approved of changes. So has everyone seen 309? Update for scaling underlay routing service tunnel private link encoding.
Yeah.
Yeah. Okay. So is next step for me, Prince, to go ahead and squash and merge then?
yeah, I think we can merge. Yeah.
Sure. Okay, I can do
Yeah,
that
we
later on.
can merge. So sorry that we delayed and haven't added any comments here, but we'll look at it often and continue to add.
You don't want me to merge it?
You can merge it, and I can probably add comments on top.
Okay, sounds good. Cool. And then do we want to go through any of this? Was just Prince, should I just delete this one or squash and merge it since you're going to do an API?
Yeah, I don't think that one we should merge because it's kind of an open-ended question.
Oh, so
that, right?
really
So I can close that and
delete / close. That was just me. Okay, great. And I need to fix the spell check on this one. I know that. I just need to make some time to do it. So maybe today. Chris, you help me with that.
Pardon me now?
I have to fix the spell check on 320. I think I can do it myself though. Yeah. So anyone else before we move on to a different topic? Any PRs you guys want to talk about?
PR 301, I had some comments yesterday from Anton. I fixed them, so I think we are ready to merge.
301 ready to merge. Okay. So I hope you guys can see okay. This one is adding SCI API test for change, update, delete operation. Okay.
Vijay from Keysight, right? I'm so sorry about that.
Yeah, that's right. Vijay from Keysight.
Got it. Thanks.
Okay. Sorry, I'm just taking a quick look. Okay, got it. Okay. Anyone else, or should we move on to picking up the metering conversation? So let's do that then. I can either stop presenting and let, was it Vijay talk about this or Sanjay?
Yeah, I'll share my screen.
You want to share?
Vijay.
Okay.
Yeah.
Okay, Vijay. I'm going to stop then. And thanks for doing this, by the way.
Sure. So, yeah, can you guys see the screen?
I can. Can everyone else?
Yeah. Okay. So just a quick recap from where from what we had discussed last time. So this is the new outbound packet processing pipeline where we have the metering policy lookup coming after routing, and we have the metering update block, which is also which was already there, but this is the place where the metering buckets get updated. So no changes here, and this is just the zoomed in view of the pipeline. I think there were a couple of comments here and kind of incorporated them. So I guess one was this, there was some confusion about this, the TX and RX bytes, whether it represents ENI or it represents how the flow is established. So I think we have some clarification on that. So this is the TX and RX is ENI centric. So just like renamed it as ENI transmit bytes and ENI received bytes. So doesn't matter which direction the flow is established, but the accounting is always ENI centric. And we also have included a direction bit going into the meter table, which helps us decide which counter to increment, transmit or the receive counter. So this is just to, based on the comments from the last meeting, we just updated this diagram. No other changes, everything remains the same. So any other comments here? Then we can move on to discuss the bucket IDs.
In Prince,
Go ahead.
go ahead. Okay, thank you, John. Prince had added 3 types of metering, right? Policy-based, route-based, and there was a mapping table-based, right? These, especially mapping table-based, applies to the outbound pipeline. Because it's not applicable to inbound. So how are we taking care of those different types of metering here in this lookup?
So yeah, so basically the meter bucket ID is coming from 3 different tables. If you notice in this pipeline, we have the policy lookup, which gives the meter bucket ID. The routing gives the meter bucket ID, and mapping also gives the bucket ID. So given the fact that there are 3 points where the meter bucket ID is derived, we just need a way to like a precedence policy to determine which bucket ID is the final bucket ID which goes into accounting in the meter table. So the routing has a meter policy enable control. So routing lookup decides whether the meter policy should be looked up or not. And if the meter policy lookup is enabled, then the meter bucket ID coming from the meter policy table takes precedence over the meter bucket ID coming from the routing table. And going further in the pipeline, you have an override Boolean coming from the mapping table. And if this Boolean is set, then the meter bucket ID coming from the mapping lookup takes precedence over the meter bucket ID coming over policy or the route. So that is what is kind of depicted in this pipeline. Of course, all this would have to be will be represented in the behavioral model P4 changes as well.
There is a decision made whether we should do the meter policy table or which lookup has to be done at a given time.
So the routing has the control over whether policy lookup is performed or not. So yeah, so I guess this is this kind of incorporates all the requirements and the different scenarios that were put forth in the requirements. So basically,
Go ahead, please. So which means outbound routing table will always be looked up anyway, and that will make the decision of the metering. Okay.
Yes, yeah, that's right. Yeah.
So this is the routing table per ENI, right?
Yes, correct.
Not the entire routing table.
No, this is the per ENI routing table.
Okay.
So you can see that there's a ENI ID and dip going into the outbound routing table.
Hey, this is Bud. I have a question about the inputs to the meter policy table. The IP address there, the CA dip, is that the same input to the outbound routing table?
Yeah, so this is the packet IP, incoming packet inner destination IP. So this is the CA destination IP.
Okay, and so for the outbound routing table, the inputs are the ENI ID and the CA dip. Then at the top here, you have the ENI table where the policy meter ID is taken from.
Right.
Isn't it true that the E&I table is just a sort of a remapping of the E&I ID to the meter policy ID for the input to this table? Like, I'm not sure how the meter policy table is actually doing something different than the outbound routing table.
Oh, okay. So I see. So the meter policy table has prefix and priority based lookup. So there is which is like the outbound routing table does like a LPM based lookup. So the lookup types is the way the lookup is done in the pipeline is different. I guess the priority is not shown here, but there is also the IP and priority bit which goes into the policy. So it is not a strict LPM lookup.
Okay, so what's the requirement for the policy? I'm sorry, what's the requirement for having a priority?
Oh, yeah, I think that is because there was a case where if there were a multiple prefix overlap and there is multiple matches, then you needed the priority would decide which meter bucket would win. So it could be a case where there are multiple hits due to overlapping subnets, and there could be in that case that you need to have a priority to decide which entry takes precedence.
So there's a need to be able to configure non-longest prefix match behavior, I think you're saying.
Yeah,
Yes.
so basically, I think one of the requirement that that's captured as metering is, let's say if you have packets going to internet, right? So it could match any default routing table, right? In that default routing table, we cannot have just one metering bucket to account for all packets going to internet. So in that, we can have, let's say, some specific IPs to be metered separately, right? So then you can associate a meter policy to this default route LPM entry, and the meter policy can have different destinations to be metered differently.
Okay.
Yeah.
Does it matter what the destination is?
No, this is like adding a flexibility to have that kind of metering.
But
yeah,
this is John, but we're sharing a microphone here, so
Yeah.
Like, wouldn't that just mean that you just have two separate LPMs, like one that you use for routing and one that you use for meter policy? I guess the concern is that once it's not an LPM, then it's like, it's a much more complicated, algorithm.
Right.
Yeah. So
No, sorry. Maybe I think there's a clarification here, right? So
Yeah.
I don't think the override is between the routes within the single tables, right? So overriding the parties between different between different matching point, right? So this overriding that is meter policy versus routing pointing to the meter packet, right? So that is the overriding there. It's not within the table you need to do the override, right? So
yeah. So I think physically also these are like two separate tables. One is a LPM lookup, pure LPM based lookup, and here it's a policy with IP plus priority based lookup.
I mean the meter policies lookup is just priority based, right? So
correct. Yeah.
Yeah. So that is not LPM based.
Yeah. So I think there is, I mean, there's no way to unify the tables if that's what the question is, because these are like different types of lookups, which is happening.
Yeah, so I mean, unifying would be great, but I understand maybe they can't be unified. They have to be independent tables, but the concern is more about the algorithm for LPM plus priority, and why it's not just straight LPM.
No. Okay. This part I want to clarify. There's no LPM plus priority. Which are we saying the metering policy is LPM plus priority? No, I don't think so. Right. So which part?
That's what I heard.
No.
It's
Meter
a
policy table is
prefix.
simply a priority based table. There's no LPM on the meter policy table, right? So.
It's prefix and priority. So whatever priority. Yeah.
No. What do you mean by prefix? I mean, there's no LPM, right? So.
It's not LPM. It's a. I mean, it has a priority and some prefixes. If that you just match the prefix, and if it is a higher priority, you pick it up. There's no LPM. If there is a.
So for the, is there if it's not an LPM, is there an exact match? Is that what it is?
Oh, it's not.
It can't be.
No, it's not
an
exact
just
match.
right off the rules table. Are you guys just talking
It's a
about
prefix
that
match, right? So no. I think no, it's not
So
it's not an LPM match.
If it's higher, you take this one or that one.
So Gohan, you said it's a prefix match, not an LPM match.
No, it's not. It's just it's like I think it's very similar to the echo policy, right? So you have a priority, within each rule you have a like a TCAM prefix match, right? So
So that's
you have
ternary. It's a ternary match.
it's a ternary match, yes.
Ternary match is okay, but how big will that be? Will it be as large as the routing table?
Sorry, say it again.
How large will that be if it's a ternary match?
How large that be? I mean, internal implementation, I don't think it's, I think people have various ways to implement, just like the way they implement the echo. But do we have the scale requirement for the meter policy table, Prince?
I don't have the scale requirement, but it is not that heavy table.
Can you find out the scale requirement for that table?
Yeah, I will update that. Yeah.
It will not be as large as the outbound routing table, right?
No, it's not.
Okay.
It's not.
Okay.
Does that help, Bud?
Yeah. So the lookup algorithm, it's ternary basically. It's a TCAM.
That's what I heard.
Yeah. But you can use the various way to simulate the TCAM, right? So yeah.
And
is this metering policy table a different table than the rules table? Like what is this?
Yeah.
Is there any definition of a metering policy table?
Yeah, so this is different from the security rules table in the pipeline as well. So the definition itself is here, like from the schema point of view, you have a meter policy with the priority and a prefix, which gives a meter bucket ID. So you have a policy and a policy ID with the V4, V6 plus meter rules. It's kind of modeled similar to ACLs.
Mm-hmm.
Thanks, Vijay.
Everything.
Okay, so I guess going forward, so yeah, I mean, I think if this part is okay, we will obviously the behavioral model changes with the P4 changes to represent this pipeline will also be coming. So I guess we just wanted to make sure that everybody is in sync with this pipeline. So the P4 changes will reflect this one.
I just have one question. Where it says override, it doesn't have any algorithm. Like, how does it override? Is there an algorithm in which one it selects?
No, so the override is something that is programmed from the top. Of every mapping entry can have an override control to decide whether the meter bucket ID coming from the mapping is overriding or not. I guess the use case here is specifically for private links. You want the private link mapping buckets always to be used for accounting. As opposed to anything else coming from routing. So that's the use case where the override would be set for private link mappings.
I see. Do we have this in any writing, like, so people understand that? Is it in the document already
Yeah.
that it says that?
Yeah. Yeah, this is
Okay.
like, I think Prince has spelled it out in the
dash-sonic-hld,
requirements. Yeah.
Okay, good.
It's also there in the FTP schema to Gerald, if that helps.
Yeah. Yeah. So there is a override Boolean coming here.
Cool. All right.
It might
So
help
the
out.
override boolean is SDN managed, right?
Correct. Yeah. It's coming from the controller. Yeah.
Yes, yes, yeah.
Yeah, I guess the specific use case is the private link use case. Yeah, the idea here is to keep it generic as override Boolean rather than have any specific type checks. So yeah, in the future, if there is some other use case where override is required, you can just do that.
So why this override is only overriding the routing table, but not the meter policy table?
So Gohan, that one, when you assign the meter policy to a routing table, you know, like it is for the policy, right? Otherwise, you will not associate that meter policy to that routing table. But you don't specifically have control between the routing and the mapping table. So that's where you want to separate.
So, but for the figure, there's a 3 arrow go to the override, right? So you know the meter policy, the meter bucket ID from the policy table, and from the outbound routing table, then from the say 2 p.m. mapping table. So why?
Yeah, I think the thing is, okay, this is just a representational diagram. I think I've just like merged these two arrows going here at this point, right? So the decision to pick which one is already made because the policy enable, if policy routing says policy enable, then the bucket ID from policy is the one which is going here to this override
Then
decision.
the description on that document need to be updated, right? So it's not just overriding the routing meter bucket. It could be it could override the meter policy bucket ID as well, right? So.
Yeah, I think I guess the way to look at it is the requirements is basically giving a specific order of priority, right? And this pipeline is enabling the requirements to be met by configuring in the appropriate way, right? So.
No, I get that part, but I'm just saying the description of the overriding the in the config DB or FDB need to be updated to reflect what do we mean by override?
Oh, I see. Okay. Yeah, I guess here you mean we need to say it's override coming from policy or the metering policy or the route table.
Yeah.
Little blocks of pseudocode work wonderfully for precision.
Sure. Okay. That is something we can do.
So I think this thing from configuration, either it will be the route itself, either points to, if it is pointing to the mapping table for the VNet, then I guess that that route entry will not have meter policy enable in real deployment, I guess, right? And the meter policy enable will only be there for direct routes, which is pointing to the internet. So it's kind of exclusive in that way. Is that right, Prince? That's the idea, right?
Yeah, that's our deployment. Yes.
Yeah,
that's right.
Well, that was
so I
simple.
mean, okay, I mean, I don't know, like in that case, so the meter bucket ID from the metering policy table will not even go to the override, right? So.
It's after the override, it says.
No, I mean that means
Correct.
there's no case that the meter policy table will have a conflict with the CA2P mapping, right? So.
Right. That's right, Gohan.
So you're saying if all this is good, we can put it in P4 and make a couple of updates to the documentation? BJ?
Yeah.
Yeah.
So yeah, I think that like in the P4 at least there is a meta field, right, which carries the bucket ID. So like I guess that is only a single field. We would have to appropriately update that bucket ID in the pipeline. So I guess it'll be more clearer with the P4 changes as well. I think this diagram is just a logical representation.
Awesome. Okay, cool. Maybe we can get through slide 5 this time.
Yeah. Okay.
So who would assign, VJ? I mean, maybe I'm just jumping ahead on the P4 side. You said it might become clearer on the P4, but who would set up that meta field in the P4 for this bucket ID?
So this is like any other table attribute which is derived in the pipeline and carried in the meta, right? So in the pipeline, you have the table results which is carried in the meta field in the pipeline, and then it goes forward, and that could be involved in another decision. So I think, like for example, in VNet we have a similar case where we have the destination VNet coming from the route, and mapping also gives a VNet. Then there is a similar override happening in the P4. So we would have to do something like that in the P4 logic.
Okay, so it's essentially it will be the result of the match action lookup, and then perhaps one of the action ID parameters would set up this thing, right?
Right. Exactly. Yeah.
Okay. Thank you.
Okay. So I think we can. Okay, so going forward, yeah, I mean, this is just to introduce just to like further clarification on the metering bucket ID concept. So here we have a bunch of bucket IDs, which is like you have the bucket ID 1 to N, and each bucket ID essentially represents a type of traffic. So in this particular example, you have bucket ID 1 representing peered VNet 1, and bucket ID 3 can represent a direct route to internet WIP and so on, right? So now you have each of these bucket IDs are mapped to an ENI. And in this example, like bucket ID 1 and 3 is mapped to ENI 1, which internally allocates a hardware resource, which is doing the actual accounting. So you have like two actual hardware resource, two buckets, so to speak, in the hardware, which is doing the TX and RX bytes accounting. So yeah, just to kind of see why this particular mapping is required, right? So if we look at the way the billing is done, the billing is done at a ENI level. So the hardware resource is also at a per ENI level. But the bucket IDs themselves are associated with mappings, which are at a VNet level, right? So, and not all the, all the bucket IDs which are associated to the mappings are need not be required or relevant on an ENI. So if we take a case like you have ENI 1 VNet A, which has a peering relationship with VNet B, VNet B can have a bunch of bucket IDs. And not all the bucket IDs on VNet B is actually relevant on ENI A. So to optimize the resources, you need to associate only the relevant bucket IDs that are used for each of the ENIs. And this, the part where you actually do the association is when the hardware resource actually gets allocated. So that way you avoid having to allocate all the buckets on every mapping table. So you only allocate the relevance one for that ENI. So, and once this association is done, you also have a query on an ENI to get all the metering buckets associated with that ENI. So for example, I guess this is the part where, because the billing finally is done on a per ENI basis. So you want to know what are all the buckets which are associated for an ENI. So you can say like, for ENI 1, give me all the buckets, and that would give you like bucket ID 1, this many TX and RX buys bucket ID 3 and so on, right? So then it would give you a way to derive the final billing number on a per ENI basis. So this is what this just to clarify the concept of the bucket IDs and why that actual association is required. And
Wait,
this association.
can we look at the? I still don't understand this part. You say the bucket ID is not associated with the ENI, right? So it's a VNet concept because it's associated with a particular mapping table. The mapping table is at the VNet level, right? So
Yeah.
But not all the bucket IDs derived from mapping table. There are some bucket ID derived from the meter policy, the routing table. Yeah. Those are already on the ENI level, right? So
yeah, right. Yeah, they are at the ENI level, but I think we need to have like a unified view of the bucket IDs, right? So we can't exclude the mappings, and mappings are definitely at a VNet level, not at an ENI level. So to accommodate the bucket IDs at the mapping and to associate the bucket IDs at an ENI level, we have to come up with a scheme like this where you associate relevant bucket IDs to the ENI. Otherwise, you might end up.
Where is the schema that you do the association between the bucket ID and the ENI?
Yeah, so this is the schema for all the metering related AppDB schema. So like policy and meter rule we've already discussed, and this is the something called as dash meter that is being introduced, which is like associating a bucket ID on a per ENI basis. And this bucket metadata is an optional string that the controller can use to associate any metadata or any semantic information associated with the bucket ID when he creates this dash meter. And there is also the counters which are read-only.
This intelligence of associating or creating the bucket IDs per ENI is available only in the controller, right? Is it? Okay. And then there should be like a dash API that will call that the system can make a call to and retrieve all these bucket IDs per ENI and program them down, right? Okay.
Correct. So I think the expectation here is that when you do a dash, so the dash meter object itself will have associated CRUD APIs. So when you do a create on ENI, bucket ID, and you can do a get on ENI, star. So that would give you all the bucket IDs associated with the ENI.
Okay.
So where do you create the bucket ID along? I mean, this is creating the binding between the ENI and the bucket ID, right? So where do we have a schema that creates the bucket ID along?
No, so the bucket ID is just a number, like a UN32 number that is coming from the top, because that is something that has to be managed and passed down from the top, because the meter create itself carries that bucket ID.
So let me ask this question, right? So, because you talk about, that is, the bucket ID associated with the mapping table is on the VNet level, that we get it.
Mm-hmm.
So, but the bucket ID could also associate with a meter rule, right? So the meter rule is already associated with the VNet level. So for a bucket ID that's supposed to be associated with the metering rule, do we also need to create this dash meter table with ENI on that one?
Yeah, so yeah, that's a good question. So basically what you're asking is, since the bucket at routing and policy is already at a ENI level, why do we need to do the association again, right? So yeah, I mean, this is something that yeah, it is a derived information, so to speak, but just to keep the API simpler, right? We can, if the association happens for all the bucket IDs which are associated with that ENI, if a create is done, then there's nothing that the lower layers have to derive, right? So it is kind of already derived at the top, and you just associate each bucket IDs. It doesn't matter whether it's associated at a policy route or a mapping. you just associate the relevant bucket IDs to the ENI. So we can keep that API simple rather than have some, like some logic which is passed down to the lower layers. Right.
So, hey Vijay, isn't it true that bucket IDs are a shared resource? In other words, they are shared between multiple ENIs within the VNet?
No.
Correct. I mean, so
no, the bucket ID may be shared resource, but the bucket is not.
Correct. Yeah.
Huh? So bucket ID is shared, but bucket is not. But buckets are identified through bucket ID. Why? I didn't get it.
No, that's a confusing. I think that's what I'm also trying to understand. But it seems like this is a little bit weird because normally, right? So I coming from Hanif point of view, I think usually your bucket IDs identify a unique bucket, which is having this counting resource of TXT packet, TX and RX packet, right? So
yeah,
but somehow what design here is that this bucket ID is kind of a class ID. So it just specify, this, they have this class of traffic, their friend name. And then when you create that meter table ENI plus bucket ID, you actually create a real bucket ID.
Right. I think
because
that's the hardware resource. Like ENI plus bucket ID is the hardware resource. Bucket ID by itself is not a hardware resource.
Yeah. Because I think the key here is to recognize the fact that the accounting itself is at a per ENI level, right? So the accounting happens, the way to think of a bucket is ENI, and a bucket ID gives you the actual accounting resource. But what the bucket ID represents, or the semantic meaning of a bucket ID, is what is carried with that bucket ID. So, like, I mean, that's why we put this example just to make it more clearer, right? So the bucket ID 1 represents a peered VNet 1 traffic, or it could be a peered VNet 2 traffic, and so on, right? So that, and this peered VNet 1 traffic is associated with ENI 1 and 2 because it has a peering relationship with VNet 1. Hence, that bucket ID needs to be associated with ENI 1 and 2.
So I think from a mapping perspective, we are not interested in getting counters for all the packets that or traffic that is going through that mapping, right? So it's just based on the ENI is what we need. So if we have bucket ID to VNet, and if all the accounting happens on that, it's not something that we are interested in.
Okay, and all the bucket IDs, they incorporate all the 3 different types of metering, right? Everything in this one set. Meaning.
Yeah. So you mean this from policy routing or mapping? Yeah. Right. So the bucket ID itself is like the UN32 number, which is associated with policy routing or mapping.
Sounds good.
Maybe it should be because
I think we were like we were trying to this is something that given the requirements, right, where you have bucket IDs representing the class of traffic, and you also have the requirements of having to account at a per ENI level. So this seemed like an appropriate approach where the association happens from the top, and the accounting.
But I think I feel like the dash pipeline, the P4 pipeline, I feel, at the hardware level, they are really operating at this, the real bucket ID level. So therefore, I'm thinking like on the slides 4, that bucket ID should be the real bucket ID, right? So.
Correct. Yeah.
So then in that that bucket ID, you know, in the metering table, there should be no ENI ID there, because that is actually because you will create actual bucket ID at the hardware level.
Right. Yeah. So that is more like implementation specific, right? So how exactly?
The dash pipeline is implementation specific. It is define the data plan behavior.
But Gohan, this thing there though, you see, for example, if we had a mapping entry with a bucket ID, some bucket ID X, right? Now that same X per ENI could have different counters. So there is in the hardware resources, there are multiple resources.
Yeah,
with,
no, I get that part. I get
Mhm.
that part, but that mapping, you know, so first, I think in the number 5, we shouldn't at the AppDB level, we shouldn't call it bucket ID. We should call it the metering class ID.
That makes I was saying that makes sense.
We need to make that is a class, right? So that is a traffic class. That is a class ID. That ID is allocated by the application, so they know, okay, what type of class, have this all the metadata associated with the class, right? So, and when we go to the actual hardware, right? So we should really do as this bucket ID. Then the bucket ID is really meaning that this counting resource per TXRX plus is the bucket ID, right? So then the allocation, how to map the class ID associated with each ENI and create a real bucket ID is managed by the side that do the translation. The reason I think it's reasonable to do that is if we go to the slide 4. If you go to the slide 4, right? So then the meter table is going to be an index-based hardware table. So right now, the meter table, you have to, okay, I need the ENI ID, I need the bucket ID, it's kind of I don't know, like how do we do the search, right? So it's becoming a hash table, right? So but really the bucket ID is the index table. You just need a index and each hardware, because they will know, okay, which ENI I really need to create a bucket ID, which ENI I do not need a bucket ID according to the class mapping, right? So therefore, you just derive the bucket ID, and then the meter table become an index table. So therefore, a lookup is going to be more efficient.
So the meter policy table, the meter policy table depends on ENI. The outbound routing table can depend on ENI, but that outbound CAPA mapping table, does it depend on ENI, its results at all? Maybe only indirectly through the VNet ID? I don't even know.
Yeah, it's indirect because it's a VNet level mapping.
Yeah. So hey, go ahead. So I guess you're right in the sense that but I guess the fact here is that is more like the hardware implementation specific, right? So if you're looking at the behavioral model P4, the behavioral model P4 can have a meter table with the ENI ID and the bucket ID as keys, and you can do the accounting on a TX and RX basis. But in the hardware, yes, it can be a per ENI index table, or it can be a hash table, which will take the bucket ID and then derive a smaller bucket ID and so on, right? But if you're looking at the behavioral model,
you mean the class ID and ENI, right? To drive the bucket ID. Eventually the index, right?
Correct. Yeah, exactly. So I think that part we didn't want to break it down and show this because like behavioral model allows you to define like an ENI ID and bucket ID as keys. And it allows you to drive the TX and RX bytes, right? So that how exactly the table is implemented in a particular hardware pipeline can be flexible because some vendors can implement it as
No,
a hash
actually,
table.
I
Some vendor
disagree
can do
with
it.
that. I disagree with that argument, right? So the reason I disagree with that argument is that I think in this way, it's becoming the way that we implement the counting resource is becoming very application driven, right? So and it's not good in a reason for a reason that for example, if someone want to count it differently, right? So then it's not good, right? So, but if you aligned with all, I mean, traditionally those counting, how the counting is done is that on the metadata, it's always transferring the real bucket ID in the pipeline, right? So this, at the data plan level, I think it's more understandable, how this is done, right? So then in this case, the the bucket ID implementation or representation in the P4 is more traditional, right? So people knows, okay, what does it mean by bucket ID? And whatever rules I want to count the bucket, I just sign the bucket ID there, and and they map to that meter table, right? So, and in the meter table, I just look up the index and find the bucket and do it, because why we create another interaction between this logical P4 pipeline and the hardware implementation.
Yeah, but I think the other way to look at it is from the SAI API point of view, right? So for the SAI API or for the meter table, you want the bucket ID which is coming from the top, right?
No,
and the hardware is something that the libsci layer can manage. For the particular implementation.
No.
Okay.
Actually, on the SAI level, I want you to create a bucket ID on that on the hardware level, and that mapping ENI class ID to that bucket ID should be managed by the application. When I say application, means org agent.
Are you both talking about the same bucket ID, Guhan? Because I believe when you are saying bucket ID, you mean to say that one index, and I believe what Vijay is basically talking about when this bucket ID is basically saying that tuple of ENI and the bucket class. So
let me clarify here, right? So first, I think in terms of terminology, right? So currently the bucket ID should be really renamed to meter class ID, which is coming from the application. Then in the dash pipeline, I think we should have the bucket ID that is mapping one-to-one to the hardware. And whenever in the following discussion, in the reference, when we say the bucket ID, it's referred to that concept that is one-to-one hardware mapping. So that should be exposed by the SAI. Now the SAI will create all this bucket ID, and then the org agent need to do that mapping between the ENI and class ID to create a unique bucket and attach it.
Right. Yeah, I think the intention here is exactly as you described. So I guess semantically, that's exactly what we were also thinking. But I guess what you're saying is, I guess the meter bucket ID in this pipeline is referring to, that's why we call it global meter bucket ID. But yeah, I do agree that a class ID might be more clearer. But yeah, I guess that meter bucket ID allocation part is something that we were thinking is the responsibility of the libsci layer, which is below the SAI API. And how exactly that meter bucket ID is allocated is something that can be opaque, right? So I guess you are saying break it up into two tables. That's what in the behavioral model as well.
No, I'm not. No, I'm not saying break up two tables. I'm saying that get rid of that. The management doesn't belong to the SAI. That mapping of the ENI to the bucket ID does not belong to the SAI functionality. SAI should be a simple abstraction of exposing the hardware pipeline. So why do we want, this is the resource management about how many actually hardware resources we want to create, how many bucket we want to create. Why do we want to put that this resource management into the SAI? Why that managed by the org agent?
So I guess then can you just clarify on how the SI API would look in that sense for the meter table?
Okay, so for the SI API, right? So what I think, okay, so first in the P4 pipeline, let's clarify that. In the P4 pipeline, the meter table should be a simple index table, right? So each index corresponding a real hardware counting resource, right? So the SI API would simply just expose that meter table. So okay, so when I do the SI, I just say okay, create a meter entry, and then it will create an entry with TXRX, and then you know this you will get a side object ID, right? So as a return, you will just get a side object ID. So
So
and
how
that
do
is that is exactly mapping to a specific hardware bucket ID, right? So that is the side API I would imagine.
how do you
Does
further
how does
map it back to the ENI?
sorry, what's that?
So Gohan, a quick question on this one. So so you are suggesting a table that is a global table, a flat table of bucket indexes. So essentially you have 1 to I don't know, maybe 1 million, right? So 1 million buckets are there, and then the 1 million indexes are there, and then you can allocate one index. But then how do you further map it back to the ENI?
Yeah. Let me explain it, right? So I'm about to expand it, right? So that's a simple side API that that site provides. Okay. So then at the application level, we can still use whatever the format. If you go to that HOD showing that meter format. Yeah. This meter table, we can continue to use that. And instead of here, just add a note, this bucket ID should be changed to a class ID, right? So whenever we create this, dash meter table, ENI plus class ID, then under the side, in the occasion, it will call that create meter entry side API create actually the bucket ID, right? So then,
so then it's the org agent is managing the per hardware resource, so it knows how many buckets per ENI and so on.
Yeah, of course. So then, let me think, right? So, so how does the hardware do the mapping, right? So then there's a gap here, right? I think you need to be, look at the pipeline that the org agent will associate that bucket ID with some either this metering rules or the the routing rules that will point in directly to the hardware object ID, right? So that side can do that. But I think on the
but Gohan, these routing and meter rules are created upfront before even this mapping can happen.
Before which mapping can happen?
This dash meter association can happen. This meter rule will be created in hardware.
Sure. I mean, I don't know that what does it mean, but you have to resolve that dependency, right? So if you don't have the hardware meter created, then you create that rule that pointing to that meter table. It doesn't work, right? So you basically have to create the meter first and then create those rules, right?
So one more, there is ambiguity there. There is ambiguity too, because if you take a metering bucket, some class ID or class allocated on a mapping rule, that has projections to different bucket IDs on different ENIs, right? So it cannot be. So what this thing I'm trying to grapple with is, so what goes in the mapping entry, which ID goes mapping
So
entry because there
where's the
are
current mapping tree? Okay, where's the current mapping tree there? What is the current mapping tree say here?
it
Yeah,
just
this
says
is the direct
ID,
bucket ID, which is
the
used.
class ID. If you want
The
to call it,
class
I think
ID or
maybe we
whatever.
can
Yeah.
just call it the class ID now. Yeah, it's
Yeah.
just
Yeah.
the class.
Here we cannot associate a real hardware
Correct.
bucket ID.
We cannot. Yeah.
You cannot. You should not. And then you should
Right.
create another table. You should create another table to do that mapping. You know, to you know, to
Yeah.
real you know, this class ID. You know, this class ID and the ENI, and then you know mapping to a real bucket ID that you have created before, right? So
right, I think that is the
that is
proposal,
what
right?
is happening here. Yeah, that is the proposal. Yeah. That's exactly what is happening here in this meter table box, right? The ENI ID meter bucket ID is going into the meter table, and the hardware implementation is either managing it as an index table, like you said, or a hash table, and so on, right? Which is more implementation specific.
The hardware can only give the information of TXRX count with ENI ID, right?
no, I mean,
what else can we get from the hardware expectation here?
Yeah, so I think from the hardware, what we are saying, so if you take that logically, what is happening here in the pipeline, this much can be represented in BMV2, right? So this BMV2 allows you to take an ID coming from a big ID, which is a bigger number, like a UE32 number coming
I
from.
think nobody is arguing that this cannot be represented by BMV2, right? So I think we're discussing whether this is a right to be represented by BMV. This is the right abstraction being provided by SI. I think we're putting too much logic in the SI to manage the hardware resource, which I want to move away from that.
Yeah, most of this can be done in software.
So yeah, so Gohan, I think just few minutes back, like we were doing that exercise of mapping, right? So I guess we realized that the ID or the class ID that is coming from is the global ID, is the big number, right? Which needs to go into the meter table. So I guess the only other way is to push the hardware ID allocation to the top, to the ORC agent, right? So the SI API itself takes the actual hardware ID. Where it takes the class ID and maps it to a per ENI hardware ID, and then you call that SI API with both these numbers, so the hardware can directly take the hardware ID that ORC agent has mapped and use it directly. But it looked like that is pushing too much of the hardware details into ORC agent. So we thought that itself can be something that the libSci layer, which sits below the SI API, can do that, right?
No. As I said, right? So this is about resource management. I think if you expose that global metering ID to the application, it will be much easier for the application to do the resource management. Because it's okay, what is the limitation? You know, I can easily do the CRM. I know, okay, what is the consumption of the metering table? How should I manage it? Right? So instead of pushing all those those logic into the side, then okay, I don't know how to how to do the CRMs now. How do I know actually how many? Because the hardware they will have a limit on how many real back ID they can create, right? So they give you this one, you use it as a global resource. It will be much easier for us to tracking, what is the resource consumption. But however, if you do this indirect mapping, then I actually don't know at the application level. Actually, don't know how many hardware bucket I actually created.
Right. So, but isn't it similar to any other table in BMV2 currently? For example, if you take a VNet table currently, right, you have VNet ID, which is indexed into a VNet table, but there's a separate resource available SI API, right, where you can query and then get how much resources available on the table, right? So I think, yeah, I guess we are making the org agent simpler. So he just takes the whatever is coming from the top and just puts it down. And the libsci layer is managing the actual hardware resource. So if we had an API on the meter table, which on a per ENI basis, it gives you how much resource is currently available, which I believe Sai already has those semantics, right? Then it would, you leave the actual management of the table to the libsci layer, and you keep the org agent and double layer simpler. That was our thinking.
But no, I think, I mean, all KGN implement once and work on every platform, right? So, if I want to just write once, right? So why would I want to every side vendor to replicate the same logic in their side library instead of I put this logic into the org agent, and we'll have better testing stories there as well.
Would it be okay to pick this up next time, or should we keep going, guys? It's 10:03.
I think we can
go ahead.
resolve. Maybe we will need to resolve it offline, but
You think
I
so?
think this seems like bring complexities. I mean, the interface between the data plan and the control plans looks not as the most straightforward way to be represented.
Okay. All right. Well, maybe we'll, VJ, I hate to do this. Maybe we'll carve out 15 more minutes next meeting.
Yeah, sure.
Okay. All right. It's been a very informative meeting. Thanks, you guys. I'm sure you have to go to a different call, but I'll stop the recording, and you guys have a good day.
Thank you.
Thanks,
If
Kristina.
that's